Okay, the recording is started. Okay, so welcome to the first lecture. So let's see what we are going to discuss in this particular course. So if you look at the course handout for this particular course, uh, now uh, the name of the course is Engineering Design, but here the focus will be on more or less product design, right? So the engineering part will be less, and it is more of product design from the syllabus perspective. So, which means what we'll do in this course is we'll first of all try to understand product development as a process, and we'll actually go through the process of product development, and we'll learn each and every step in that. And of course, through our assignments and through our evaluation components, we'll also test, how much we have learned, right? So, if you look at the objectives of the uh, course. Now here, understand the fundamentals of the design process. So by the design process here, what we mean is the product development process. So the first step here is to understand what the customer needs are, or the customer's needs are, and convert that into engineering specifications. So before you actually develop a product, you have to understand what the customer wants, and you translate that into engineering specifications. When we say engineering specifications, we translate the needs into some numbers, some meaningful numbers that we can use for our engineering process, right? Okay. So then we'll go through concept development, and so you learn the process of how to come up with different concepts using structured methods. So of course, there are concept development methods and there are concept selection methods. So here you learn how to develop concepts. So if you're going to develop a new product, how to come up with different solutions for this new product. Of course, your product is going to solve somebody's problem, right? So how to come up with a solution, how to generate many different solutions, and how to pick the best possible solution. So now that process you'll actually learn and you'll understand. Then finally, after you come up with concepts, now of course you have to translate that into something that an engineer understands, or a technician understands. So that means you need to communicate this in the form of diagrams, right, in the form of drawings, in the form of descriptions. So how to communicate your design, right? How to communicate your idea. So in the concept development phase, you'll actually communicate your idea through drawings. Then after that, during the engineering design phase, you'll actually communicate through models. Then in the final phase of the design, you'll actually prepare drawings, engineering drawings, and through this you communicate your ideas, right? Then there are a few concepts, design for excellence, right? So under that you have many different topics. So we'll discuss all those different topics, such as design for reliability, safety, and etc. Right? So there are so many: design for manufacturability, design for assembly, design for serviceability, and so on. So you have so many different concepts under design for X. So we'll discuss all that. So so far you're able to follow what we are going to learn in this course. Sorry, voice is not coming. So now others can hear me. Only Vinod Singh is saying voice is not clear. What about the others? Yeah, so others can hear me. Okay. Okay, so any questions on the course objectives? Any questions on the course objectives? Okay, so now textbook. Now textbook one is engineering design by Dieter, right? So this is one textbook. And textbook two is product design and development by Ulrich and Eppinger, right? So now you can use both. I would prefer textbook number two, right? So textbook number two is my favorite. But if you want to follow textbook number one, that is also fine, right? So you can pick any of these textbooks and follow, but you may have to refer to other books also. Here we have some reference books. David G. Ullman, Mechanical Design Process. That's again an excellent book. So now there are many topics, and for each topic, one textbook will be better. Now, if you look at textbook number 2, that is good for the entire product development process. Now, there are some special topics such as converting the customer's uh, needs into engineering specifications. So we have a method for that. Now, that topic is covered well in David G. Ullman, right? So in this reference book 1. So that covers that particular topic really well. Now, if you look at the overall smaller processes like engineering, design, and analysis, and so on, some basic descriptions are given well in textbook number 1, right? So overall, textbook number 2 is probably the best because it covers everything. Textbook 1 goes through some of the basics. Reference book 1 is good for some special topics, right? Then apart from that, you have a reference book 2. So if you're going to do design from a reverse engineering perspective, right? So that means if you're going to take somebody's product, dissect it, study it, and then make a duplicate or something similar, much better product. So if you're looking at design from a reverse engineering perspective, reference book 2 is a good book. Then apart from that, you have another book here, Product Design Fundamentals and Methods, right? So reference 3, again, you can read if you want, right? Textbook number 2 is here. You can see it. You can see my oh, sorry. I didn't share my screen. Okay, now can you see my screen? Sorry, I didn't share my screen. Okay, now here you can see all the textbooks, right? Now, can you see my screen? Okay. Now here you can see it. Now again, I'm just opening the course handout. Now you have this course handout in your eLearn portal. So all you have to do is just download this course handout from your eLearn portal page. And now what I'm showing is just a course handout. So you didn't miss anything. So course objectives. Now you can see my screen, right? All of you can see my screen. Okay, good. Okay, so now this is what I was showing. So, so course objectives, textbook number 1 is here, engineering design by Dieter and Linda Schmidt. Textbook number 2 is product design and development, Ulrich and Eppinger. So it's here. Now, reference book 1, mechanical design process by David G. Ullman. So now this is the book which is good for a few topics. Textbook number 2 covers the product design and development process overall really well. Textbook number 1, T1, is actually good for smaller topics, right? It just covers pretty much the entire syllabus from a very fundamental perspective, right? From the very basics. So it's totally your choice. You can pick textbook 1 or 2. 2 is good from my perspective, but if you want the entire syllabus to be in one book, then textbook 1 will have it. Textbook 3 you can actually refer. Now, if you know how to download textbooks, probably you'll be able to download 1 or 2 of these books if you want. Now, the best thing is to buy one hard copy, and probably get some online resources to support you. Right. So now after this course, what are your learning outcomes? Now, after this course, what will you be able to do? Right. So at least this is what we expect you to learn right after the course. So now, after going through this course, after studying this, writing all the exams, doing all the assignments well, right, you will be able to interpret your client's requirements and limitations. Right now, somebody is coming up with some requirement, you will be able to understand that, right? So you'll be able to interpret the customer's requirements. Now you will be able to understand that those requirements, and you will be able to communicate that to your team. Then you will be able to develop engineering specifications. So now if somebody is saying, I'm having some problem, I need this solution, then you'll be able to understand that he is having a need, and based on that need, you will be able to come up with what is needed to meet his need, right? So that's what we mean by understanding somebody's needs and coming up with engineering specifications. Now you'll be able to prepare some models and drawings, right? So now there is a lab component for this course, right? So I'll explain about that. then you will be able to apply some of the fundamental concepts in design for X, right? Design for excellence. Then if there are multiple solutions, you'll be able to select a particular solution based on the advantages and disadvantages. So that means there are structured methods for selection of solutions. You will be able to understand all those methods, right? So these are the learning outcomes. So the topics are divided like this, right? So in the first few lectures, first 4 lectures, these are the topics. So definition and concept of design, right? So what do we mean by design? Uh, uh, how do you define this process? What is a good design? What is not a good design, right? So that is something you'll understand in the first lecture. Then product development process, right? Phases of design. So now here, if you see this table on the rightmost column, reference which book for which topic, right? So that is mentioned in the last column. On the rightmost column, you can actually see class notes, chapter textbook, chapter 1, section 1.1 to 1.5. So textbook 2, chapter 2, like that, it is mentioned here. Now you can also go through this column before making your textbook purchase decision, right? So that is also fine. So team behavior and tools, textbook 1, chapter 4, opportunity identification, textbook 2, chapter 3, like that, everything is given here. So uh, now for QFD, this is one particular topic. So that for that, reference book 1, chapter 6 is good. So like that, I've mentioned, what textbook for what topic. So everything is there on the rightmost column. So you can just look at that. Now, then concept generation, decision making, concept selection, then embodiment design. So till this part, you'll have for the mid-semester exam. So that means first 8 lectures, whatever topics we discussed, those topics will be given for the mid-semester exam. Then remaining topics, detailed design, material selection. So now under detailed design, you'll actually go through industrial design as a process, uh, some design validation methods. Then after that, you have material selection. Of course, the material selection has to be done at the beginning, but here this topic is covered in detail, so it is coming as a as a separate topic, as a separate lecture. Then we have design for manufacture, design for assembly. So design for X, all those topics are here, right? Then risk, reliability, and safety. Then cost estimation, how to estimate the cost, how to come up with decisions based on cost. Then last topic, we'll discuss some intellectual property rights, some legal issues, ethical issues. Now, what are the things you should and should not do, right? So all these topics we'll discuss in this course. Any questions up to this point? Soft copy of all the books, I'm not supposed to do that, right? So you can buy the hard copy of one book. The others you can try and download. I'm sure somebody will be able to help you. But if the book is available online, you can try and download it. Otherwise, you purchase one hard copy, right? Okay, which one should you refer for the exam? Now, just like what is mentioned, right? Just you just follow what is mentioned. See now, textbook 2, chapter 16. So now, if you see uh, textbook 2 and textbook 1, both are used. Any one book. So now, if you want to go with textbook 1, that is fine. If you want to buy textbook 1 and follow the class notes, because I'll be using material from textbook 2. So that means textbook 1 and class notes will be able to give you everything, right? Rest you can try on your own, right? So textbook 1 and class notes should be fine. Uh, if you want to choose textbook 2, then you have to again refer class notes for materials from textbook 1, right? So that's how the class materials or class notes, the PPTs will have materials from both the textbooks. So if you buy one textbook, that should be sufficient. But textbook 2 is what to say, it focuses more on the product development process. So that if you are interested in that particular area, then yes, you can buy textbook 2. Otherwise, textbook 1 is good for the course. Okay, now we have a lab for this particular course. So experiential learning. Uh, so we'll introduce you to CAD modeling. So I'm sure most of you will be, or at least some of you will be working in CAD, but some of you may be working in manufacturing or in other areas. So if you're going to develop a product, what are the tools that you should be familiar with, right? So what are the resources that you should use, right? So like CAD modeling, preparation of detailed drawings will actually take you through the process of how to prepare a 3D model using CAD, how to prepare drawings, right? How to perform computer-based analysis. So for this, we'll be using Fusion 360. It's a software which can be downloaded. You can actually download a student version of the software. So a lab faculty will be teaching you this part, and you can practice it and you can submit lab assignments, and there'll be a final lab exam also, right? So so solid modeling, preparation of detailed drawings. So analysis using a finite element analysis software. So Fusion 360 has a finite element analysis also. So some fundamental concepts will be introduced to you. So how to perform a basic stress analysis. So that part will be introduced to you, right? Now, as a part of work integrated learning assignment, now you can take one problem from work. If it is related, you can identify opportunities of that you come across at work, right? So some client might be coming up with a problem, so you identify that as an opportunity and you come up with a solution. So that is something you can do as an assignment, right? So so along with the regular assignment, you can take this assignment, or you can take this part as your regular assignment also. So regular assignment will have a set of questions, and you can include this part, right? So the lab experiments are shown here. So creation of a 3D model, creation of an assembly, creation of detailed drawings, specifying tolerances in drawings, then stress analysis and thermal analysis. So all the fundamentals that you need uh, for preparing a good design, or coming up with a product, right? So all the basics that you need will be covered here. But beyond that, you have to practice. Of course, one course cannot teach you everything that you need to know, but we'll introduce you to all the different topics. Beyond that, you can learn on your own, right? George Dieter, yeah, that, see, as I mentioned, one textbook is enough. The remaining part you can use class notes, right? So here, sixth Indian edition, yeah, this book is good enough, or even an earlier version is good enough, right? So there won't be much of a difference between a previous edition and the new edition. Okay. So any questions so far? Yes, everything is clear. Okay, now let's start discussing the topics. Okay. Okay, now in engineering design, right, or in product design, we come up with uh, new products, right, depending on the needs of the customer, right? So in today's lecture, we'll discuss uh, the definition of design. So what do we mean by design, right? How to define design as a process. Is it a science, or is it an art, right? So you can actually view it on both perspectives. So what is it, right? How to look at design as a process. Now we'll go through some of the basics of the process. What is a good design, right? Now, if you look at a regular product, right? Now, for example, here you see a stapler, right? Here you see a dove kneader, right? Now, if you look at all these products, now one thing that you see is that they perform a function, right? They perform a function. They have several different parts, and the parts are all connected together in a particular way. And there is a method to operate this, right? So you have uh, a way to operate this particular device. And there are internal parts which are connected, which work in a particular way. Then it performs that particular function. So that is something we know, right? So it performs the function that it is intended to do. Then beyond that, if you look at this particular object, it looks nice, right? So it looks attractive uh, from the appearance perspective. Now, if you just look at it as an object, it is not something which is crude or ugly, right? It is very nice with smooth corners, right? Very polished surfaces. It's an attractive product. So similarly, if you look at this product also, uh, it performs the function. The parts are all connected well. It works really well. But apart from that, it looks very attractive. It has got smooth surfaces, very attractive colors, right? So all these things are put together, right? So based on that, what do we mean by design, or what is design, right? Okay, so if you look at the definition of the design process, right? So what is design, right? Now here there is one definition. To design is to create something that has never been, right? So this is not always true. uh, this is one way of looking at it. Nothing uh, has existed like this before. You're creating something totally new, right? So in that case, that can be a definition of design, right? So that's possible. This may be one way to define design. But if you see, companies are constantly designing something, but the product has existed before. Now, for example, if you look at automobile companies, right, companies making two-wheelers and four-wheelers, they keep designing new cars and new scooters, new bikes. But cars have existed for 100, more than 100 years, right? So several uh, decades cars have existed and they've evolved. So now here, that means this definition is not 100% correct, right? So it's not always something new. Now here another definition: put together something new or arrange existing things in a new way to satisfy the need of the society. So that's one way of looking at it. So you may put together things and make them work to satisfy a need. So this is another way to define design, right? Now, third definition: establishes, define solutions to problems, right? So here you're coming up with solutions to problems probably not solved before. Now here again, they are talking about problems that have not been solved before, or new solutions to problems which have been previously solved in a different way, right? So again, a different way of looking at it. Now, if you look at it from a company's perspective, right? This is the process of organizing or organization and management of people and information in the evolution of a product, right? So this is probably, from a company's perspective, for products which keep evolving, this is a better definition, right? This is the process. Design process is the organization and management of people, information they develop in the evolution of a product, right? So this is okay. Now, any definition is okay, but here these are somewhat, the first three are somewhat specific to new designs, right? Now, if you look at design, is it a science or an art? It is both a science and an art, right? So uh, now I actually mentioned two aspects. Now, if you look at a product, the working of the product, how the parts are made, how the parts are connected together. So now that is uh, definitely a science or engineering. Now, how the product looks, right, from the shape, from the finish, corners, colors, that part is definitely art, right? So you have to apply uh, both the concepts of science and art in order to come up with a very effective or a good design, right? Okay, now of course we'll go through some more aspects. Now, in the design process, you will come across analysis and synthesis, right? What do we mean by analysis, right? So now if you're going to develop a product, you have to solve a few complex problems, right? So now what is this part going to do in service? So that means when the product is working, what is this part going to do while the product is working, right? So in that case, what load is going to come on that particular component? And for that, what material do you have to choose? What dimensions do you have to choose? Right? That means you have to perform calculations, right? So one load is going to come on one part, right? So you may have a part which is pivoted on this side. You may apply a force here. Another resistance may come here. So now will this portion be able to take the load, right, and perform the function? So that means you need to choose the right material, you need to choose the right dimensions, and the proper surface finish and everything for this part to perform the job. So now for that you perform calculations, you do computer-based analysis, right? So now that part is called analysis, right? That part is called analysis. So where you analyze it, you perform calculations, you do computer-based simulations, and you study the the nature of the problem, and then you solve it. You come up with solutions, which means you select the correct dimensions to take these loads, and then it's going to work perfectly, right? So that is analysis. Now then after that you have synthesis, which will help us identify the design elements. So that means you break the entire product into different parts and how they connect with each other, right? Finally, you come up with a solution that is workable, right? So overall, you put together the different parts needed and you make them work. So that part is synthesis, right? So then now these two processes will always be there in any particular design, right? Okay, now for design, what do you need, right? Here there are 4 C's of design. So whenever you think about design, or whenever you try to solve a problem, creativity is definitely needed, and creativity will definitely help you, get ahead. Now, by that I mean, see, now when you are trying to make a product, it should not always be a copy of somebody else's product, right? So if you simply try to reverse engineer somebody's product and you offer that as a solution, then yes, you can be a follower, but you'll not be a leader, right? So if you want to lead, and if you want to get a larger share of the market, then you have to be creative, right? So in design, creativity is definitely needed. So that means you should learn to think on your own without being influenced by others' designs, right? So that is a fundamental requirement for being successful in design, right? So requires creation of something that has not existed. See, now this part was mentioned earlier. So now this is related to creativity. So that means if you're going to create something that has not existed, that means you have to definitely be creative. So you have to think with a totally fresh mind, with a totally open mind, welcoming new ideas. Then finally, something creative will come out, right? Okay. So something that has not existed before. See, now if you look at this particular product, so I've just put simply one example, right? So people have come up with ideas like this. Now we may have experienced this need, right? Now all of us may have experienced this need. So need has been there, right? But somehow we'll manage. We'll put our hands, in front of the baby's forehead, and probably while giving a bath, you'll probably put your hand here, and you'll prevent water from going into the eyes of the baby, right? So something like that, we may have experienced, we may have felt the need, but somebody has come up with a solution, right? So that means this is a solution, and this is a product, right? So if you search online, you'll probably be able to buy this product, right? So the need was felt by everybody. All of us must have felt this need, right? The need must have been felt for generations, but we somehow found solutions to solve this problem. But somebody has been very creative to identify this need, and based on that, come up. He is able to come up with a product, right? So that's where creativity helps. Now, this is a very simple example. Of course, if you look at the products which are available in the market, and if you look at uh, products being developed by companies, now there's a lot of scope for creativity. A lot of things can be made much better with totally new ideas, right? Now, products can be very complex. Now, designs can be very, very complex, right? So now, in this particular case, look at the example of an engine. Now, even the companies that manufacture vehicles, all of them don't manufacture engines, right? they actually buy engines from some other company and they use it, because here this is a very complex system. So you need to uh, deal with many parameters right now. For example, if you take an engine like this, now first of all you have to deal with materials. Now you have to choose the right materials, right? There are so many parts which are connected together. Then you have to work on the design to produce the best possible efficiency, and you have to manage the heat, you have to manage the lubrication, right? For a better life of the engine. Of course, you have a mechanical system, you have an electrical system, and the mechanical system you'll have, you know, a fuel supply system, right? An exhaust system, a lubrication system. Now in the electrical system, you have an ignition system, right? You have a power generation system, so on. See, now you have so many things put together in this one small product, right? So here, complexity is a part of design. So if you are dealing with such designs, then complexity is something that you have to deal with. So you have to deal with many variables and many different parameters, right? So variables are things that change, right? Parameters, by parameters we mean all the inputs, right? So whatever inputs you have, uh, they are called parameters. Now parameters can have some variables. Certain things will be constants. Now material properties will be more or less constant, but variables, the fuel flow, air flow, right? All these things will keep on changing. So those are variables. So you have to deal with all these things while designing a product like that. Now, choice is again a part of design, because you will have many solutions, you'll have many different options, you'll have many different materials, you'll have many different design possibilities, and many different manufacturing processes. So you have to choose a particular material, and based on that, you can choose a few manufacturing processes, right? So depending on your material selection, depending on your design selection, depending on the size of the part, you have to choose different processes, right? So for smaller sizes, for a particular shape, you can choose one particular process. Now, for example, if it is a cylindrical component, you will choose turning as a process, right? Uh, if it is, a slot that has to be cut, then you can use milling as a process. If it is a thick component, if it is a thin component, a simple laser cutting will actually help you, right? So depending on the nature of the component design, depending on the size, material, you have to make choices. And once you make that decision, it's very difficult to change it also, right? Because the process is evolving. So once you complete this particular design, you're going to go in for manufacturing. At that point, you cannot come back and change your design, right? At least not by much, right? Okay, now during this, you have to make a lot of compromises, right? So you have to, when you choose one, which means you're compromising, you may be compromising on the other, right? So if you choose a lightweight material, for example, right, for producing a lightweight design, I might choose a lightweight material, I might choose a plastic material, but the plastic material may not be as strong as a metal component, right? So that means I'm making a compromise here. By going for lightweight, automatically I'm compromising, strength, right? So again, if I want strength, if I choose steel, then I have to deal with the weight, right? So how to make a compromise, right? So now if you look at the modern motorcycles or cars, they have a lot of plastic parts. So wherever strength is not very critical, or you know smaller strength, or lower strength will not cause any major damage, at that point they choose plastic, right? Where strength is critical, they choose metal. They use a combination of both. For example, mud guards of motorcycles are made of plastic nowadays, right? Because even if they break, nothing is going to happen. But the body, the chassis is made of metal, right? In some cases, even fuel tanks are made of plastic, because nothing's going to happen. Even if you strike it with some object, it's simply going to deflect, it's not going to break, right? So uh, that way we have to choose materials, and while we make one decision, we have to make a compromise. So we have to deal with the 4 C's of design, right? When you are doing design, you have to deal with the 4 C's of design. Yes. Any questions till this point? Any questions? You're following, right? You didn't fall asleep. Yes. Any questions till this point? No, you can hear me, right? So, okay, thank you. Okay, now if you look at the outcomes, now what kind of products do we develop, right? What are the outcomes, right? So now here you can come up with many different products. Now overall, if you see, your design may focus on a simple component, right? Now if you look at the entire process, right, when we say design process or the product development process, you may come up with a major uh, system like refrigerators, power tools. Now these systems will have many different components, right? A missile system, an entertainment system. DVD players are probably outdated, but you have modern television systems, right? uh, jet trans. All these are examples of products. Now, depending on the complexity of this product, you will actually spend a lot of time and effort and resources to develop these. Now, for example, it takes about 5 years to even uh, build a jet plane, right? So if you talk about uh, the product development process, it takes much longer time, right? It takes years to develop a new aircraft, right? In some cases, it may take even 10 years or 20 years to come up with, an advanced aircraft. Now, for example, military aircraft will actually take many number of years to develop because it has to be the best in the world, right? Uh, so depending on the nature of the products. Now, refrigerators, if they are developed by companies which are already manufacturing refrigerators, it will probably take anywhere from 3 months to 1 year, right, to come up with a new product. But if somebody new is starting to build a refrigerator, it will probably take even longer, right? Now, in some cases, you may deal with a much complex engineered system also, right? For example, an electrical power generating station or a power plant, right? A petrochemical plant. Now, in the case of civil engineering, a building is also, a product, right? A bridge, maybe a complex engineering system, right? Or engineered system. So these are, very complex systems. So we may be developing something like this also, or we may be developing products like the ones listed, right? Okay, so why is the design process so important, right? Now, if you look at many of the Indian companies, right, they prefer manufacturing than that is manufacturing to design, right? Why is that, right? So if you try to understand this particular uh, picture, you will actually clearly understand why many companies prefer to manufacture something instead of totally developing it. Now, when you manufacture something, that means you're buying the design from somebody and you simply manufacture it. And of course, there is a market which you have identified and you're selling it, right? So that means the risks are already mitigated, or somebody has already solved the design related problems. And finally, what you have are tested designs, right? So in that case, all you have to do is simply manufacture and sell it. But if you're going to design something new, you see what is happening. Now, when you're starting your design, depending on what material you choose, what manufacturing process you choose, what size, dimensions, and so on, you will decide on processes, right? So, for example, if I choose a plastic part, that means to manufacture a plastic part, I have to choose a process, which means I may choose injection molding as a process. Now, to do injection molding, I have to prepare a mold, right? A mold made of metal. So that mold is extremely expensive. Then the injection molding machine is also extremely expensive, right? And then I have to take multiple trials. I have to do divisions on the mold. I have to make modifications on the mold. And then finally, I'll have, after multiple trials, I'll get a product. So that means if I make that decision here, right? See, now I may make that decision that I'm choosing plastic. But when I choose plastic, look at my cost committed, right? Now, even at the conceptual design phase, that means once I choose a plastic component, I'm committing to so much cost, right? So, which means the moment I make this decision, I'm making a decision that I'm going to spend so much for the injection molding mold, that is injection molding process, the mold, the machine, right? And the number of trials it will require to finalize the final component, right? So this is cost committed. Now, at this stage, you're not spending that much money, but you are already committing, right? So you see products, you have to deal with conceptual design, and finally you have to go through the entire design process. By the time you go into manufacturing, you see you are incurring less cost. Now, at this point, you're actually buying machines, but you have already committed. So now, which means if you make a change here, uh, see now, once you come up with this initial design, see now, I cannot change anything here. At this particular point of product design, I cannot say, let's forget plastic, let's do something else, right? We cannot do that because we have already made that decision, and accordingly the cost is committed. So accordingly you have placed an order, right? That means you have started the process of designing the mold. So things are parallelly happening. At this point you cannot change anything. So the decisions that you make in the design process will have a very large cost related impact, right? So that's what is seen here. So even though you're not spending so much money during the design process, you're committing to a big cost which cannot be changed later on, right? So that's why this risk is something that people try to avoid by simply buying a design and manufacturing a product, right? Because if you make one wrong decision, you'll end up spending even more money, right? Okay. So any questions related? See now, when you say parameter is a general term which is something that controls the performance of a system, right? Now, for example, I may have an equation. Uh, okay. Now I may have something like ax plus by plus c, right? So this is something. Now I can relate this to, yeah, let me call this as z, right? So now all these are parameters which contribute to the performance z. Now z may be my efficiency, right? Z may be my power, right? Everything uh, can be written in the form of an equation like this. So that means all these which control z are parameters. Now in that you have variables x and y, right? Mathematically we use x and y for variables, and everything else a, b, c are constants, right? So in the case of variables, we mean something that can change, right? Constants will not change, uh, too much, right? We can say they'll remain constant within a particular range, right? So that's what we mean. See, when we say parameters, we consider everything. When we say variables, things that will change, right? So that's a fundamental difference. Otherwise, all are inputs. See, prototyping, see now, I'll go through the design process, then you'll understand the difference between conceptual design, detailed design and so on. So here, this is just to give you an idea of how much cost we are incurring at the design phase. But prototyping is something that comes, after the initial design process is over, right? So prototyping is building a model that comes, after the initial design is over. Before going in for manufacturing, that's when prototyping comes. So I'll explain the process. We'll discuss that. Conceptual design. See now. Okay, so we'll discuss that. Um, see, conceptual design. When we say we will. Okay, now I'll give you an initial idea of what we mean by this, but that's what we are going to discuss in the coming lectures, right? So whatever you see here, right, all these things we'll discuss in detail in the coming lectures. So, uh, okay, so I'll just give you an idea. Now, if you're going to solve a problem, right, you have some need from the customer. You have somebody is telling you a problem. The problem is engineering related. Now you are an engineer, somebody is telling you that he's having a problem in doing a particular task. It may be an engineering problem. So in that case, you come up with solutions, right? So what can be the solutions? So the problem may be that he is not able to lift a very large stone, right? So there's a very big rock sitting there and he is not able to lift it and move it. So that may be the problem. So now here, what are the solutions? You may find a solution. You may come up with a device. I may come up with a device like this, which can lift the stone, and I can connect it to a hoist, right? I can lift it like this, right? This is one solution. So that means this is one concept. Or if this rock is here, I may bring a forklift. I can simply bring a forklift and lift it, right? I can just bring a forklift like this and simply lift it. This is solution two. This is a concept, right? Now, like this, I can come up with many different concepts. Now, each one is a concept. Now, see, I'm just doing a sketch. I'm simply drawing a sketch. This is a concept, right? So I've not solved anything. I've not designed anything. I've not performed any calculations. I'm just simply coming up with solutions, right? Just to lift an object, right? Or, somebody might come up with another solution. Put a small stone like this, put a rod like this, roll it. You roll this rock, you roll it and move it to the side. So that is another solution. So now this is concept number 3, right? So you come up with a solution and you put a sketch, you make a sketch of that solution, or you write a description of that solution, then that is a concept, right? Now, here this concept is too simple, right? Now, in an engineering problem, for this, you may have to sketch a mechanism. You may have to sketch, many different mechanisms put together, right? So that is conceptual design. So you come up with sketches, you come up with mechanisms, you put together those mechanisms. Multiple mechanisms may be connected with each other, and overall you solve a problem. So that is conceptual design. Then after that, you go in for your proper engineering design or product design. In that one phase, you'll actually do that's called embodiment design, right? So we'll discuss again later. So now this phase is called embodiment design. So that's when you give an actual form to the product, right? So those are different phases of design. We'll discuss those in detail, right? So don't worry about it now. So some words are put here and there, so that may confuse you. But this is it. Concept is coming up with a solution and sketching that solution. In the case of embodiment design, you come up with the framework for building the actual product. So that means you have to come up with the size, shape, thickness, and everything. For that, you have to perform calculations, right? So then after that, you'll prepare solid models and you'll make drawings, right? Okay. So at least conceptual design, you understand what it means, right? So when you say product design, we mean the entire process. Now, starting from identifying the customer's needs to delivering the final product. So that entire thing is product design. Conceptual design is one small part of it. Embodiment design is the next part of it. Then after that, you'll do a detailed design, which is also a part of embodiment design, right? So embodiment design is a slightly broader spectrum. Starts with performing calculations, analysis, modeling, detailing, and so on, right? Finally, before you go in for manufacturing, you'll build a prototype and you'll actually test it. Then you'll perform smaller revisions. Then after that, you'll go for manufacturing. So now we'll take one phase at a time and we'll actually do this in detail. So which means, collecting the customer's requirements alone will actually take, quite a long time. Then after that, conceptual design, we have a long process. We'll do all that. We'll practice with actual examples. Okay. Okay. Now, what is the importance of the design process? So now when we are talking about the importance, what we mean is from a cost perspective, right? Okay. Now if you look at, now here there is a much clearer picture given. So during the design, you spend about 5% of your resources. That means you have your budget, right? Imagine you're going to spend 10 crores for developing this product. So you're spending only 5% of that money for design. So that means your engineer salary, your CAD software, your computer, all the time that you spend, right? That is only 5% of your entire budget. But the impact of that is going to be 70%. So that means you make one mistake during the design process, that's going to have a very big effect, and it's going to be very difficult to solve it, right? So again, if you see material, it is about 50% of the cost, right? But the impact is very small, right? Labor, 15% of the cost, only very small impact, 5% impact, right? Then overhead costs, your rent, your electricity bill, and so on, they're going to have only 5% impact on the product, right? So if you see what is impacting the product, its performance, its reputation, success, so on, whatever it is, right? You're developing a product so that the company can manufacture it, sell it, and make money, right? Pay salaries, and contribute to the society, pay taxes, right? Overall, if you see, this company will actually pay you salary, pay the government taxes, and of course it provides employment, indirect employment, to so many people. So overall, it's a part of the society, right? So everything depends on design. So if mistakes are made, then the impact of this is huge, and because of that, the company may go out of business. Very simple, right? So that is the impact of design. So that's what is mentioned in the previous slide, right? So uh, this whatever is mentioned in the previous slide is given as a picture here. So design has a very large impact, even though the amount that you spend for design alone is very, very small, right? So there are some examples here. Importance of the design process. Now, this is a vehicle which is developed in the 90s, right? 1997 Mercedes A-Class, right? So they just wanted to come up with a slightly different design, and in the process, they ended up increasing the center of gravity, or they just ended up moving the center of gravity upwards, right? So because of that, what happened? So when you just take a very sharp turn, this car will simply lift off, or this will simply roll over, right? So Mercedes A-Class, during a moose test. Moose test is where you just drive the car in a zigzag manner, take a sharp turn, and this car was failing. So this was a failure model, right? So now, can you change it? Can you modify it? Nothing can be done, because you've already designed this product. All the tools for manufacturing this product have been made, right? Now suddenly you cannot change it. Now you have to come up with an entire new design. Maybe you could use the engine, maybe you could use some of the parts, but this car which is designed, it's going to be of no use, because this is failed. It is having a problem, right? So now, can you compensate that in manufacturing? Can you do something in manufacturing to compensate this design error? No, you cannot do it. So if you make a mistake here, nothing can be done. You have to redesign it, you have to revise it. You cannot compensate in manufacturing, right? Now, what is shown here is actually an aircraft which was developed in the 1950s, right? So after the Second World War, uh, a British company was actually developing an aircraft. So now that is called de Havilland Comet. So this aircraft was the predecessor to Boeing, right? So even before Boeing company became very popular, so this company was there and it was selling aircraft. So what happened was, this was flying. So now it was a jet aircraft. It was all flying very well. People were traveling from one city to another city. Now before that, they had only military aircraft. They did not have, of course they had some passenger aircraft, but they did not use jet engines, right? So at one point, this aircraft, was using jet engines, so it was able to fly much higher and much faster. The problem was, after several hours of operation, right? So that means after several cycles, so that is after working for a few years, suddenly this aeroplane will just burst in the sky. Initially, they did not know what the problem was, so they were simply using it. Again, another issue happened. So again, another accident happened. The aircraft was bursting in the sky. More people died. Again, this happened. This kept on happening. So at one point, they actually started studying what the problem was with this particular design. What they found was, this particular aircraft. You see this? This is having square windows. The windows are square or rectangular. If you see the windows are rectangular now, just like railway windows, right? Just like trains, uh, the windows are rectangular or more or less like square. And because of that, when you have a square window like this, now from the corner a crack can actually form, right? So like that, cracks were forming from the corner because of stress concentration. Now if you have something like a rounded window, now this problem can be avoided a little, right? So when you have a square window like this, because this aircraft will be pressurized, right? Because it had jet engines, this aircraft will fly much higher. Uh, at that point, you'll have very low pressure. So in order for the people to breathe properly, the aircraft will be pressurized. Now, because of this pressure and the low pressure outside, the aircraft will actually expand a little bit. So the aeroplane will expand and contract, expand and contract. This will keep on happening. So now this happens even to the present day aircraft, right? So they expand and contract, expand and contract. That keeps happening. And here, because of these square windows, due to this expansion and contraction, this crack started happening. So after this, they actually ran a test to find this out, to prove it. So they took an aircraft like this, they put it under water, they pressurized it, depressurized it, again pressurized it. They just kept on repeating the cycles. Now after around 20,000 cycles, a crack was appearing, right? So which they studied. So after this, this plane got stopped. They stopped manufacturing this plane, and after that, Boeing company learned from the mistakes of this particular company. They came up with better designs, and they became more successful, right? Uh, so here the problems are with the design. So it's not that the company did not have enough money to build the product. They had enough money, they had all the resources, they were able to build such a big product, but the problem was in the design, right? Material selection, design, parameter selection, right? Overall, the shape of this window is the parameter that determined the failure here, right? So uh, whatever happens in the design phase, it will have a very large impact on the life of the product, the reputation of the company, and overall whether the company is going to function or not. So that itself will be decided by the design, right? So uh, that's what is summarized here. Decisions made beyond the design phase can influence only about 25% of the total cost. So cost, in terms of product quality, right? Uh, Everything totally depends on the design, right? Of course, a lot of things are dependent on manufacturing also, right? Of course, you don't manufacture it correctly, then it's not going to work properly. Nobody's denying that. But if your design is fundamentally wrong, even your manufacturing process is the best in the world, still the product will not survive, right? So that's what we are trying to make here. So even if you have a very good design, if the manufacturing is bad, yes, the product is going to be bad, no doubt, no doubt at all. But your manufacturing is perfect, your design is bad, no, there's no chance the product will survive, right? Okay. Now again, design determines the product competitiveness, right? So again, the product cycle time. Now by this, how quickly can you develop a product, right? By this we mean how quickly can you develop a product. If you can develop the product quickly and launch it in the market, that is a good thing. But there is a problem, or there's a negative side, which is you will end up making mistakes when you're developing a new product, and somebody else will learn from it, right? Now, if you're coming second into the market, you will probably learn from the mistakes of others, right? So, but whoever enters the market first will have a clear cut first advantage, right? So that means he's entering the market with the first product. That means everybody's going to buy that product. But you have to be careful, right? You have to choose what you want, right? So from this, from all these slides, here we have the summary. Decisions made in the design process cost very little in terms of the overall product cost, but have major effect on the cost of the product, right? So whatever decisions you make, later on, it's very difficult to change it. Now, you cannot compensate in manufacturing for the defects introduced in the design phase, no doubt. Now, the design process has to be conducted so as to develop quality, cost competitive products. See, now you come up with the best product, but if it is very expensive, who's going to buy it, right? Cost competitive products in the shortest possible time. If possible, you come to the market as quickly as possible, right? So if you can do all that without making any mistakes, then you'll be successful. Okay, what happened here? Uh, okay. Any questions till now? Okay, so time is 9:23. So we'll just take a break for 5 minutes, right? Uh, so we'll come back at 9:29 or 9:30, right? So 5 minutes break. If you have any questions, you can type your questions on the chat window. 5 minutes break. Okay, welcome back. Can you hear me? Shall we start? Okay, so you cannot just say value engineering. So that's one way of looking at it. But product design, see, the most important part of product design, even before conceptual design, see, now you have to understand what is needed. So understanding the customer's needs is the most important thing in product design. So you have to give a lot of importance to how to understand the customer's needs. So that is a major part. That is a very important part, at least not, in terms of time, it may not be big, but in terms of the success of the product, that's a very, very important step. So if you simply say conceptual design plus engineering, then that's not correct. Understanding the customer's needs, then you translate that to engineering specifications, then conceptual design, you come up with concepts, then embodiment design. So at that point, you can apply concepts of value engineering, how to provide value, right? All that you can apply there. But overall embodiment design phase. So at that point, you try to give an actual shape to what you have in your mind. So that is embodiment, right? Try to bring in a body to what you have in your mind. So that's embodiment design. Then in that part, in embodiment design, you have all these different steps of the engineering part, analysis part, modeling, detailing, and so on. Then you have prototyping, testing, then again design revision, and then you come up with your manufacturing tools, and then you go into manufacturing. So that is the entire product development process. So if you simply say product design is this, then you're cutting things short. See, now, yeah, you can say understanding the customer's needs, translating that. Then you have, see, now 3D modeling can happen during the conceptual phase. See, 3D modeling is just one process, right? Uh, you can use 3D modeling while concept development, while concept selection, or while embodiment design, right? So 3D modeling can be used depending on the complexity of your product, right? So you can't say 3D modeling comes after this alone. So while doing concept development, I might do sketching, but somebody might actually build a 3D model at that point itself, right? Because the product may be simple. If the product is a pen, then you build a 3D model while doing concept development itself, because it's a simple thing. You can just do that in 5 minutes, right? Right. When when you say innovative design, what you mean is you come up with something new, or you put together things which exist and create something new, right? So people keep calling this guy Steve Jobs very innovative, right? Because he puts together technology. He actually put together technologies which existed, but he put together all these technologies in a form, and finally the product was very, very new, right? The product was new, but the technologies already existed, right? So that is innovation. Now, when you say invention, that means you're coming up with something totally new, which did not exist. So that's the difference between invention and innovation. So in the case of all these tech companies, they are actually innovating because they put together technologies which exist and they come up with uh, something that is new, right? So that is innovation. If you totally design something which did not exist, then that is invention, right? Okay, so coming back to our lecture now. Okay, so if you look at the importance of design process from a cost perspective, now here they've just given one example in terms of cost, right? Now here you have an average design and average manufacturing, right? So in that case, the product is costing about $8. Let's imagine that's a very simple product, right? It's costing $8. Now, if you have a good design and efficient manufacturing, it's costing some four and odd, right? So if you can approximate it to half, right? So if you have a very good design and you have very good manufacturing, it's costing half, right? You have poor design and inefficient manufacturing. Bad design, bad manufacturing, again, it's doubling from there, right? Then good design, inefficient manufacturing, slightly more expensive. Poor design, efficient manufacturing, almost the same, right? So overall, if you see, this part is pretty much the same. But if you have a good design and efficient manufacturing, it's the cost is almost coming to half of average. And if you have poor design, very poor manufacturing, then again from this it's doubling, right? So that is something we have to understand. So the best thing is to have good design and efficient manufacturing, right? So that's what we want. This is what we want, right? Okay, so now when you're designing, you have to build quality in your design, right? So that means while designing, you have to choose the solutions. Now you will have many different options, right? So you have to choose the solution in such a way that you have quality built in, right? So while you choose materials, while you choose your dimensions, while you choose your tolerances, right, you can actually choose them in such a way that you get the best possible solution. So you should not try to cut cost by compromising on quality, right? So now you can use plastic where the uh, components, failure is not going to cause something serious, right? Now, for example, mudguard, right? Mirrors, rear view mirrors, they can be made of plastic. Nothing's going to happen. But if you now there are motorcycles where the swing arms bushes actually have plastic bushes, right? So swing arm bushes are made of plastic or nylon bushes, and something that is so critical, you should not use plastic components, right? So if you use bushes made of plastic in swing arms, then you're compromising quality. In that case, you can just use a metal bush, heat treated metal bush, things like that are possible. So while choosing the components, you have to choose, while choosing the materials, while choosing the dimensions, you can actually build in quality while you're designing the product, right? So so here you have a lot of parameters which actually influence quality: the product's performance, right? How you design the process, right? How you choose the materials. Then do you have a control point? Now is something going to tell you if something is wrong with the product, right? So you have a process control there, or do you have a control system which actually tells you that something is wrong, right? So if you build all these things, right? Now, for example, you have indicators on your car dashboard, right? So if somebody has a door open, or if some door is not properly locked, there are indicators which actually tell you that the door is not locked, right? So those are control systems, right? You can actually build those in your product also. So that something will tell you, right? So your air conditioner will actually tell you there's something wrong, right? If the fan is not rotating, it'll actually give you an error message, right? Or if there is a sensor failure, it'll actually give you an error message, right? So from the error message, you can actually find out that there's something's wrong, right? So those are systems which will actually give you feedback. So those can be integrated in your product, right? So overall, you can actually design your product in such a way that quality is built into the product. Then of course, continuous improvement is something you can do now. Every revision, every year or every 2 years, you will have some revision done on the product based on the complaints, customer complaints, service requests. You can actually modify something that solves that problem, right? Companies keep doing that. Overall, when you keep doing that, your product is going to improve, and the quality overall is going to improve. So quality can be built into the design, right? Okay. Now, before, okay. So we still have not gone into the product development process. Now, looks like most of you are very curious about the product development process, right? So what are the steps? Now, you can actually read a little bit, right? Take some of your textbooks, since most of you are very curious. You can actually start reading a little bit. We'll discuss, those concepts in the next class. But before that, we'll actually discuss the types of designs, right? What are the different design types? Now here we have a few listed: original design, adaptive design, redesign, selection design, and here industrial design, right? Okay. Now all these are different uh, classification, right? Now if you have a particular design, then you can actually put it in one of these categories. What do we mean by that? Okay. Original design is also called innovative design. Now somebody was asking, right? Original design can also be called innovative design, right? So this is at the top of the hierarchy. So that means this is at the top. This is the most difficult thing to do. So now if you come up with one original design, that means you become a part of a history book. That means you will be remembered for a very long time, right? So that means this did not exist before, right? Okay, it employs an original innovative concept to achieve a need. So when you say innovative, it also means totally new or original. But when you say innovation, it means that the solutions existed. You took all those solutions and put together in a form that gives you something new, right? So you did not invent something, but you innovated by using the existing solutions, and you put the solutions in a particular way that it has given you something totally new, right? Okay. So a truly original design involves invention, right? Now, here, innovation means that you put everything together and finally the product becomes new. Now, in some cases, you come up with something which is totally new. You did not use anything that existed, or you came up with a solution which is totally new, right? So that is an invention. So in the case of an invention, you will get a patent, right? You can file for a patent, and you can make sure nobody copies your design, right? So that's a totally different case. Now, innovative design is you put together things and the solution is new, right? Now let's look at an example. Now, when you look at this particular scooter, it looks very familiar to us, right? The scooter looks very, very familiar. Now, this is a 1946 Vespa, right? 1946 Vespa. Now this looks very familiar to us because it looks more like the Bajaj Chetak, right, which existed in the 70s and 80s. Bajaj Chetak was actually manufactured from license from Vespa. So that means this design was actually given to Bajaj, and the company manufactured scooters, right? So that's why this design looks very, very familiar to us. Okay, now here the product was developed based on aircraft design. So how did they develop this product? So after the Second World War, Italian engineers did not have jobs because their country was defeated in the war, and the aircraft design engineers did not have jobs. So they started working for automobile companies. So they started working for other automobile and other companies. So they were given the task of designing a two-wheeler, right? So aircraft engineers who are very skilled in working with sheet metal, right? So when they were given a task of designing a two-wheeler, so again, in Italy, they actually use motorcycles like we do, right? So they use a lot of motorcycles. So the need was there. Of course, women were also using motorcycles, so they also had a need there. So they came up with a design where the stressed member, so that means the entire uh, body was taking the load. So that means the body of this two-wheeler was made of sheet metal. And in the case of a motorcycle, if you see, there'll be a frame, right? So in the case of a motorcycle, there'll be a frame like this, right? A motorcycle will have a frame like this, uh, and you will mount a swing arm here, and you will mount the suspension like this, right? But in this case, the entire body is your frame, right? So that means the entire body is taking load. So the body is made of sheet metal, just like an aircraft, and the body is taking the load. So they came up with the idea of a new two-wheeler like this. So now here you have a space like this, so it was easy for women to use it. And the engine was not located on the front. See, in the case of a motorcycle, the engine will be located on the front. Here the engine is located right next to the wheel, and you do not have a chain drive. So there was more like a a shaft drive in this case. And in the case of a motorcycle, the air will actually cool it, right? The air will cool the engine. The airflow which comes from the front will actually cool the engine. But here in this case, they had forced cooling. So that means they'll have a fan here. They'll have a fan here which will suck the air and that will cool the engine, right? So they had forced cooling. So you see, they have used the technologies which have existed, engines, fans, and sheet metal body design like in an aircraft. But the solution was a totally new vehicle, totally new two-wheeler, right? With smaller wheels and more convenience built in, right? So, of course, some of us may not like scooters, but this is definitely a more, convenient vehicle. Now, if you see on the roads today, there are more scooters than motorcycles, right? So, because of the convenience. So, this was, a very popular product back in those days. And finally, Bajaj got a license of this particular product, and it was launched in India, right? So that's why this looks very, very familiar to us, right? So this is an original design. So in this case, even though it is not, it cannot be called an invention, it is an original design because a scooter like this or a two-wheeler like this did not exist before, right? This is an original design, right? Any questions so far? Okay. Now coming to adaptive design. What do we mean by adaptive design? Okay, this form of design occurs when the design team adapts a known solution to satisfy a different need to produce a novel application. Again, looks very similar, but here also you're creating something uh, new, right? Based on what you already know, right? So you're taking a known solution to satisfy a different need to produce a novel application, right? Now here you have an example, right? Now we are familiar with printers, right? Now in this particular case, you have stepper motors driving the printing mechanism, right? And of course, you have laser, you have inkjet, you have different technologies, but overall, you have some motors which move the paper, and you have a printing head which comes and prints on the paper. Now here you have CNC milling machine, right? Where again the technology is very similar. You have motors moving a tool across three different axes, and depending on the pattern that you give, it's going to machine a component. Now these are known technologies which have existed. Now if you see, based on this, they have created 3D printing or additive manufacturing. So here again, the technology is very, very similar to a regular printer, right? For advanced models, you will use technologies from a CNC machine, right? But overall, technology is very, very similar. The only thing different is the printing head. Here, you're just melting a piece of plastic and depositing it layer by layer, right? So if you see, this is more of an adaptive design. So you have technologies already known to you, but you are just creating something new from it, right? So now many of these designs are patented. So in some cases, they were considered to be uh, original designs, or in some cases they were even considered to be inventions because patents were granted. But if you see, the way this has evolved is purely adaptive. They've just taken whatever was known and created something new, and which works as a regular technology. Now this itself is evolving. 3D printing itself is evolving for plastic, for metals, right? So all these technologies are still evolving, right? So this is adaptive design. So you're taking something already known to you, and you're putting that together and creating uh, a new technology. Okay, now the next one is redesign. Okay, redesign. Now, what do we mean by redesign? So now the word itself is telling us what it is, right? Redesigning. You take it, design it again, you design it. You design it again, right? Redesign. So this may be to redesign a component. This was possible. right? You may have a motorcycle model which has existed for 30 years. You take only the mudguard, redesign it. You take only the petrol tank, redesign it, right? So that you may be redesigning just a component. This is possible. In some cases, the redesign may happen because of a complaint, right? Some component might be breaking after a few months of use, or after a few years of use. In that case, we might redesign a component, right? Make the product better. So in that case also redesign can happen, right? So now if you see most of the design that we do in the industry today, it is redesign, right? So the product has existed, the model has existed. We'll take only one component, redesign it, improve it, choose a different material or choose different dimensions and put it back, right? So that is redesign. Now, in some cases, you might redesign the entire product, right? You have a car, you sell that model for 5 years. After 5 years, you redesign the car. Again, it's a design which is known to you. Everything is the same. Dimensions only change, right? So that is a redesign, right? So now here, if you see what is defining this, or what is giving the characteristic, is that nothing is changing. Without any change in the working principle or concept of the original design. So whatever you started with, nothing is changing from there. You are simply revising it to make it better. So that is redesign, right? So now this applies to all the motorcycles, all the scooters, right? All the cars designed now, right? You are simply taking it and redesigning it, making it better, bigger, more efficient, smaller, taller, right? So all the car models are like that. One is for tall people, one is for big people, right? One is for big families, like that. You are just taking the same product, same principles, you're changing only the dimensions, right? Making something better, right? So that is redesign. Now, in some cases, you may call it a variant design, right? What is that? Now let's look at some examples. Okay, now here, redesign. Honda CB 500, right? 1976, like wonderful motorcycle. Something, like a gem. So it has got 4 cylinders, right? Uh, you see this uh, inline four-cylinder engine, excellent motorcycle. But you have the same motorcycle available today. Yeah, only the name is same, right? But you look at today's motorcycle. What is different? Now, the older model had wire wheels or spoked wheels. Now, the new model has alloy wheels, right? The older model, here itself, it has got disc brakes, right? So here you have disc brakes with, with more modern design. Now, your mudguard, side panels, everything is made of plastic. The old model, everything was made of metal, right? Now, this has got a parallel twin engine, right? Only twin cylinder engine. Now, they feel that a 4-cylinder engine is not needed for a motorcycle. They just, put a twin engine, right? Now, if you see the, principle wise, nothing has changed. Working principles are more or less the same. Small changes in technology will be there, right? It'll be fuel injected now. Back then it was carbureted. Now you'll have electronic ignition system. Back then they had, mechanical timing system, all these things. Some fundamental changes in technologies will be there, but overall nothing has changed. Same uh, fuel burning engine propelling a motorcycle, same chain drive transmitting power. So everything is pretty much the same. So they've just redesigned this again and again and again, and finally they've come into it has come into this shape, right? So this is an example of redesign, right? So you keep designing it again and again with better materials, better technologies. Alloy wheels are easy to manufacture. Uh, if you use, pressure die casting process and so on. So overall, your manufacturing efficiency has improved because of the design changes, right? So that is your redesign, typical example of redesign. Now this is true for all the cars, right? All motorcycles, scooters, and everything. Now in the case of variant design, again it is redesign, right? Now you have a motor which is how much? Half HP. Now in this case, right? Now you have another motor which is 1 HP. Now, if you look at this, everything will be the same, right? Material will be the same, working principle will be the same, only the capacity changes, right? Or just one parameter changes, just one thing changes, right? So that means, how much water this is going to pump, that will change. So based on that, they'll change the price of this. So this is available for one customer, this will be for a different customer. Same motor, they'll change size, they'll sell it as 1.5 HP, they'll sell it as 2 HP. So depending on what output you need, you will just buy one particular model. So in this case, this is a variant design. Of course, this is redesign, but you're simply changing only one parameter to choose to cater to a slightly different market, right? So that is variant design, which is a part of redesign also, right? So if the redesign is achieved by changing some of the design parameters, very few design parameters, you're not changing the entire looks, you're not changing everything, you're simply changing a few parameters, just one or two parameters, or just a few, that is variant design. So you can see variant design in all your motors, fans, right? In some cases, even engines, right? So all these things are, you're simply taking that and changing a few parameters. With that, you get a totally new product, right? For a different segment. Any questions up to this point? Yes. Any questions till this point? You're able to follow? You can hear me? Yes. Okay, fine. So next is selection design. What do we mean by selection design? Okay, now when you're designing a motorcycle, you probably will design the frame, you'll design the side panels, you'll design the functional parts, right? Now, there are things that you will not design, right? You'll simply buy from somebody and use. For example, the tires. You will not design the tires, right? You will not design the headlight or the bulb, right? Or the lamp which is inside your headlight, right? You will not design the chains, right? You will not design the bearings. So all these things you will simply purchase from somebody and use, right? So this is true for every product. Somebody designing, a truck, or somebody designing an earth mover is not going to design bearings. He's not going to design tires, right? So bearings, belts, chains, tires, or tubes, or in some cases even wheels, rims, you will not manufacture. You'll simply buy it from somebody. But bearings, belts, chains, circlips, right? Screws, nuts and bolts, any kind of fastener, you will not design. You'll simply buy from some supplier and simply use it, or you simply pick a catalog, select set of screws and simply place an order, right? So now that is called selection design, right? Now again, just because it's selection, it doesn't mean that uh, it doesn't require any technical expertise, right? So these, even though these components are purchased outside, right? So now you're simply selecting from a manufacturer's catalog. But if you make a mistake here, this will cause a serious problem with your product. So you have to be very, very careful while selecting products from manufacturers' catalogs, right? Again, there will be details given in the catalog. You have to follow those instructions. Now, some details, some instructions will be given. So you have to follow those instructions while selecting parts from a catalog, right? So that is called selection design. Now, you will need technical expertise to do this. Just because you're selecting from a catalog doesn't mean anybody can do it, right? So now fasteners, washers, right? Now, in the case of fasteners, they will actually give you what is called the stress area, right? So that means you take this area is called the stress area. So that stress area for that fastener will be given in the catalog. So that means while performing your calculations, you will be using an area, right? So for stress calculation. So that stress area will be given in that catalog. So if you're choosing, for example, M8 bolt, now the stress area will be given in the catalog. You take that value from the catalog, you perform calculations. Right now, if your bolt is subjected to a tensile load, right, that means you're pulling this. So how much stress is going to be created at that particular point? Based on that, will the bolt fail or not? Right? So all those calculations have to be performed. Then based on that, you come up with a factor of safety, right? And based on that, you choose this bolt or you go for the next size, right? So now you will be performing calculations, and based on the calculations, you'll be choosing this particular bolt, right? Similarly, how much is the area of the head which is pressing against a part, right? If the area is fairly small, then you pick a washer. The washer will help you distribute the stress over a larger area, right? So you perform the calculations and pick the washer, right? So here you will be performing a set of calculations. Based on your calculations, you'll simply pick from the catalog and it will be delivered. Right now, of course, you have to select your components from a reputed manufacturer, right? Just because it's a bolt doesn't mean that you purchase from a local hardware store and use it for your motorcycle. Never do that. Why? Now these bolts actually have a requirement for heat treatment. You have to use high strength steel, right? High strength steel has to be used. Now heat treatment has to be given uh, for achieving the highest possible strength. Now, if you buy a bolt from a local hardware store, it'll be manufactured by, a non-branded manufacturer. So he'll not choose the right material. He'll not have the right heat treatment. So it may not have the correct strength mentioned in the catalog. So that means you have to buy it from a reputed supplier who will follow the process and list that in the catalog, right? So if you do that, then you will be fine, right? So there are reputed bolt suppliers, nut suppliers, so you have to buy it from them. So they'll follow the correct process, they'll use the correct materials, right? Similarly, for chains, you have a calculation. You have to perform the calculation again, stress area for the pin, stress for the chain plates, for the bushes, right? Everything you have calculations, chain selection. Again, some of these calculations will be mentioned in the catalog itself. If you choose a chain catalog, the procedure to perform the calculation will be mentioned in the chain catalog. Or you can actually use a textbook. Any machine design textbook will actually tell you how to select a chain. Same procedure will be listed in the textbook also. Based on that, you can actually find out. And in the case of chains, the factor of safety will be very high, right? So it can be greater than 5, it can be greater than 10, because uh, it is going to experience a lot of load, a lot of shocks, and so on, right? So depending on that, the factor of safety recommended for the chain will be mentioned in the catalog, or it will be mentioned in your textbook or data book. So based on that, you choose your chain. So simply, you're performing the calculation, but you're not manufacturing it. That's the only difference. You have to do the design in terms of calculation, in terms of understanding the load, right? But final manufacturing, you're not doing, somebody is doing. You simply pick from the catalog. So don't simply pick, you perform the calculation and then pick. Now, similarly for bearings, what is the load coming on the shaft? What is the RPM, right? What is the expected life, right? How many million revolutions, right? So how many years? 5 years, every 5 years you want to replace your bearing, or you want to replace your bearing every 10 years, 15 years. So based on that, you choose the life of the bearing, and put together, you will get the probability of survival, right? So now how long do you want this bearing to last under the given load? So you will, based on the probability that you want. Now, for example, you want 99.99% probability of survival for the given life, for the given load, for the given number of, for the given speed, and so on. Then based on that, you will get what is called a static load rating and a dynamic load rating, right? CO and C, right? Static load rating, dynamic load rating. So based on static load rating and dynamic load rating, you pick the bearing from the catalog. Again, the calculations will be available in a regular machine design book. The calculations will be available in a bearing selection catalog also. Now you can download a catalog. For example, SKF bearing. You can simply download SKF catalog from the internet. Nowadays, everything is available as a PDF file. Simply search for SKF catalog for ball bearings. You can download the catalog. The calculations will be mentioned there. You can actually perform the calculation for your requirements. Now, what is the RPM of the shaft? What is the load coming on the shaft? How much load is going to come on the bearing? Based on that, again, how much life is needed? Based on that, you'll be able to calculate the static load rating and the dynamic load rating. Based on that, you choose the bearing, and you have a bearing, right? So this is selection design. Same thing is true for V belts, timing belts. Timing belts, you have the Gates catalog. V belts, you have many different manufacturers like Fenner and so on. You can simply pick their catalog, perform the calculation, then select the belt, right? So this is called selection design. Now, for standard parts, this is the best possible method. Now, you don't want to manufacture a belt or a chain because that requires a very large manufacturing facility. Again, quality control will be very difficult. So you have to simply purchase it and use it, right? But you have to perform calculations. So that is selection design, right? So you can download all these catalogs. That means if you are a product development engineer, you will have all these catalogs, on your desk, right? You will simply have all these catalogs printed and bound, and you will have them on your desk, and you will be able to simply use the catalogs, right? So, and you'll be able to perform the calculations also. So that is your selection design, which is very, very important. Selecting, yeah, fine thread screw, you can pick, see now when you're specifying a screw, you have to specify the pitch, right? Now, for example, if I specify M8 by 1.25, right, dash 20, what I mean is M8 thread, right, M8, 1.25 is the pitch. So that means 8 mm is the, see now if I have a bolt like this, so when I say M8, now this diameter, outermost diameter is 8 mm, thread pitch is 1.25, 20 mm is my length. So now this is how you have to specify. If you simply specify M8, then you have M8 by 1 also, right? Uh, so or usually they'll do this M8 dash 1.25 or M8 dash 1, right? So when you specify this, 1.25 is your coarse standard coarse thread. 1 M8 by 1 is fine. So when you specify like this, then there's no chance of making a mistake, right? So uh, then length you can specify 20 mm length, something like that. You can specify in your drawing itself. While you specify the components in an exploded view, you simply mention this. And when you prepare your bill of materials, right, you mention like this, then there's no chance of making an error. So whenever you pick a screw, automatically you have to mention the outermost diameter and the pitch and the thread. And when you say M, it's metric, right? So similarly, you have inches also, right? So depending on what you want, you have to specify clearly. Otherwise, yes, there's a chance of going wrong. Okay, then the last one is industrial design, right? Now, developing, when you're buying a product, right? Now, for example, you go to the showroom when you buy a product. Normally, what do you see? What do you see there? You'll see products which are designed with attractive colors, right? Now, you see color combination here. This is just, for example, this is just an iron box, right? Now, this can be of any color. This can be of any shape. It doesn't really matter. As long as it's ironing properly, it should be fine, right? Now, see now, all I need is a hot plate at the bottom of this iron box, right? So that means if I have a hot plate, it's going to do its job. But why are companies spending so much time in designing this contour? You see, this contour is of a particular shape with a particular color, and you see this uh, overall shape, is made like this? Any particular reasons for this? Can anybody tell me why companies spend so much time in making the product look very beautiful? Any particular reason? Aesthetic design, yes, but why? Why is it? Attractiveness, attract the customer. More than that, avoiding fasteners, glue. That is only in terms of manufacturing. For sale, ergonomics. Any other reason? Any other reason? People's preference to good looking design. Anything else? Now, beyond that, it's just brand identity. Okay. Anything else? See, now, when you can buy a regular car can carry four people. Why do people spend, five times the money and buy a BMW? Any particular reason for that? I can buy a regular car for, 7 lakhs, right? Or 6 lakhs. Safety, luxury, reliability, not exactly. I'll get good reliability with a Honda or with a Maruti. What's the problem? It can run for 3 lakh kilometers. Somebody has mentioned status. Comfort. No, no comfort. See, I can get all the comfort. I have an AC, I have a good seat. What are the comfort do you want? See, status. You see that? Now they are connecting the product to your image. See, now this is not a real need. Yeah, show off, correct. This is not a real need actually. The real need is just a hot plate at the bottom of that product. It's going to do the job. Similarly, for a car, I just need a good design for the chassis, engine, so on, which I have in a regular 7 lakh car, right, or a 6 lakh car has got everything I need for four people. But somebody is spending 40 lakhs to buy a BMW. Say in terms of safety, I can get all the safety here. I can buy a car with six airbags for 10 lakhs, right? But somebody is spending 60 lakhs, five times, six times the money. Why? For status, right? So that means they want to show that they are very successful. They want to show that they have the best quality in taste, right? So that means, they are very selective. They have a very good lifestyle. They want to show that, they choose only the best things, right? So they want to maintain that particular image. So that's the reason. So now what they're doing is, now what the company is doing is, it's taking that particular preference. Yeah, it'll stand out. When you're driving a BMW to work, people will, talk to you. People will ask you how the car is running. People will, will like to be friends with you, right? They want you to be their friend because you have a BMW, right? So you're showing some status there. You're showing some power there, right? So overall, when somebody comes to your house, you can have a regular, wooden sofa, right, with simple cushions, or you can have a very good looking leather sofa, right? So overall, you're trying to show that you're very successful. So when you're designing a product, they bring this feature into it to show that you're very successful, right? So that means automatically when you go and buy a mixie, you'll choose something like this. You're that kind of a person. You will automatically buy something like this because it has got, some tasteful designs here, which shows that, you have very good taste, right? So your cooking might be very, very poor, right? Probably you won't even cook at home. You'll probably order outside, but you'll own this kind of mixie, right? So at the office, you'll probably have a coffee maker which looks like this because it looks very nice. Now, when you buy appliances for your house, probably you'll choose, something like this, chimney like this, a dishwasher, stove, and all these things, which look very nice, right? So overall, if you see the products, a certain feature is added to all these products, which make them look very nice, smooth, very good shine, shape, and so on. Now, this particular aspect of design is called industrial design, right? So even though the name is misleading, this particular design is called industrial design, which purely focuses on the appearance, making the product look very, very attractive. And that is connected with your status, with your image, right? So when that is connected, automatically you will go and buy that product, right? So companies spend a lot of time on industrial design. Now, there are industrial designers, and there are degree programs which offer, you know, a degree on industrial design. That means you'll be focusing more on the appearance of the design, right? So it's not engineering design, it's industrial design, which means you'll be focusing more on the artistic part of the design, right? So here it is more of art. So that means just like people who make movies, right? So what kind of background has to be set, what kind of color has to be given for somebody's clothes. So like that, what color should you give here? So if you give this color here, what should be the combination on the top, right? What kind of curvature should you give, right? So such aspects of design people actually study. So that's called industrial design, right? So now a car like this, if you see a Volkswagen Beetle, which was introduced in the 60s, had a very unique design. So initially people were making fun of this design, right? But later on, what they found was this car was very, very successful because people somehow liked the design. It was very unique with very nice curves. So people actually liked this particular design, and it was a very successful model, right? So overall, it was very, very successful because of the appearance of this, right? So this is also very important. Making the product functional is one aspect of it. Of course, it is very, very important. But if your product is functional, your competitor's product is functional, both are equally good, but your competitor's product looks very nice in terms of appearance, then people will automatically go and buy your competitor's products and not yours, right? So in that case, industrial design becomes very, very important. You have to match what is in the market. And of course, your customer needs this. Your customer prefers this because he needs a particular image, right? Uh, Nano's design. So you cannot say that. See now, uh, Nano's failure again. If you take some case studies and see, of course, yeah, they initially they marketed that as a cheap car. So that was one of the reasons people actually mention. But beyond that, yeah, the image factor also was there, right? People who owned a car wanted to show that they are somehow rich, right? People who have cars, they always felt that they just were rich. But if you have the cheapest car, then nobody's going to respect you, right? That's how people felt. So that's one of the reasons. You can't say that's the entire reason. Uh, in terms of safety, in terms of actual capacity, all those things have to be seen also. Yeah, this was definitely one of the reasons. Okay, so that's about industrial design. Now, if you see industrial design, form of design which deals with improving the appeal, right? Improving the appeal of the product to the human senses, right? Now, that means when you look at the product in terms of colors, uh, shape, everything you know, is appealing. So you focus on that particular part of design. So if you see, this is more artistic than engineering, right? So that means you have to employ an industrial designer for this. Now, if the engineer who's performing calculations and running analysis thinks that he can do industrial design, then that will be a mistake, right? Unless you are trained in industrial design. So now in engineering, we don't study too much of industrial design, right? We don't study that at all. So we study more of engineering in terms of calculations, analysis, and so on. So that means you want something to look very artistic. You employ somebody who can do this. You don't simply go and do it and you won't get it right, right? Otherwise, you take training on industrial design and then you do it, right? So that is something you have to keep in mind. Okay, so what is the key to world competitive products? What is the key, right? So if you see, and see now when you say world competitive products, that means you make a product and you sell it all over the world. Now many countries are actually doing that, right? So they make a product, they sell it all over the world, and they make a lot of money, right? So if you want to do that, then you need to do high quality product design. So overall, your product design matters. So if your design is good, then of course your manufacturing is also good. Then you can at one point make world competitive products. So it totally depends on product design, high quality product design, right? So that's the key to everything, right? So any questions till this point? So we've gone through the fundamentals of design, right? Some uh, background, some design types we have discussed, right? So how design is important uh, to cost as well as to the overall product performance, right? In terms of cost, we have discussed. So any questions overall? So it looks like we have run out of time, so we'll continue in the next class. So any questions? Any quick questions? Yes, everything is clear. What could be the best piece of advice you would give to a product design engineer while designing something? See now, the most important thing, right? Most important thing before designing a product, try to understand what the customer needs or what the customer wants, right? You understand that. That's the most important thing, right? Even if you cannot do calculations, even if you cannot do solid modeling, if you understand what the customer wants, then you can put people in your project and get the correct thing. If you don't understand what the customer really needs, see now the customer may not tell you what he actually needs or what he actually wants. So that's the challenge here. Customer will not tell you what he exactly wants, but you have to understand that and you have to provide the right solution, right? So that's the most important thing. If you do that, then everything else will happen over a period of time. You will come up with one design, you'll improve it. At one point, you'll have the perfect design. That's fine. But you have to understand what the customer wants or what the customer needs. The customer will not tell you that clearly. So that is something we'll discuss in the coming lectures, right? Yeah, the customer will have a need, but he will not tell you. Even if you ask him 1,000 times, he'll not be able to tell you exactly what he needs. But if you understand that without you know after if you understand that by doing your own research or by truly observing the customer, at one point you'll be able to come up with a very good design. So that's the most important thing. Okay, so with that we'll continue in the next class. Design is very good, product is not very successful. That means you did not understand the customer's needs. You came up with a product which is good by its engineering, but the customer did not need it. Or the customer did not want it. So in that case, your product will not be successful. There are several examples of that. Product will be very good, product will work very well, but the customer did not need it in the first place, so he's not going to buy it, right? So that's where that product will fail. So that is definitely there. So this is the most important thing. You understand what the market needs, what the customer needs. Yes, you will come up with a product. Now, there are many examples of products which have failed because of engineering. Customers' needs will be real. The understanding of the need will be correct, but engineering failure, that is, you have several examples of that. But the opposite is also true. Engineering will be good, but customer did not need that product in the first place. So what's the point? Nobody's going to buy it, right? So you have to work on understanding the needs of the customer. Of course, we'll discuss the methods for that. Okay, in the coming lectures. Okay, then. Thank you very much. See you next week.